So, welcome back, children. So, now let us continue with with the alkyne. So, now what is an alkyne? A hydrocarbon with a triple bond between between two carbons. So, as I told earlier, like how we cannot have an alkene of a single carbon. Similarly, there is no alkyne of a single carbon because there should be a triple bond between two carbons, which is possible only from where? From two carbon hydrocarbon. So that is why the first hydrocarbon under alkyne is also what of the root name eth. So here also, what is the first hydrocarbon of alkyne? Eth. So eth plus ine. So what is my name? Ethyne. Okay, children. So now let us construct the structure. Now how many hydrocarbon it is? It's a two carbon hydrocarbon. So now let us draw the structure. So as I told you, how many carbons? Two carbons. And how many bonds? Three bonds. So already we have drawn one bond. So now let us draw the remaining two more bonds. So one, two, three. And these three bonds indicate what? Three electrons have been shared. So that means out of four, three electrons have been shared. That means how many more are left? One more electron is left. So and that one more electron will be shared by whom? With whom? With the hydrogen. So this remaining will be shared with whom? With the hydrogen. Okay, so that now that will be yes. Similarly, this second carbon also will share with whom? With another hydrogen. Got, children? Now let us count. 1, 2, 3, 4. Satisfied? Yes. Now this 3, as I told, it is common for both the carbons. So here also 3 plus 1, 4. So now let us derive the formula. What is could be the formula? General formula is CH. Skeleton is CH. Now how many carbons? 2. C2. How many hydrogens? 2. C2H2. So clear with this, children? So this is the formula of ethyne. Now this ethyne is, the IUPAC name is ethyne, but commonly this ethyne is referred as acetylene. Okay, very commonly it is used in weldings, okay, in soldering. Fine. So this is called as what? Acetylene, and it is of how many carbon compound? Two carbon compound. So now let us go to the next one with how many carbons? Three carbons. And what is the root name of a three carbon hydrocarbon, children? Can you now recall the name? Yes, it is prop. What is it? Prop. So this also will be what? Prop. And since it is a triple bond, what is my root name? Ine. So propine. What is the name? Propine. Okay. And how many carbon compound it is? It's a three carbon compound. Okay. Now let us construct the structure. So how many carbons, children? Yes. 1, 2, 3. I think now you are confidently able to draw the structure. Okay, children, please try. Simply don't just try to copy, you try to construct. Okay, then so now as I told, first let us we have placed the single bond. Now let us complete the triple bond because it is a triple bond hydrocarbon. So 1, 2 and 3. So now three bonds are satisfied. So now start balancing the remaining electrons. So now let us start with the first. 1, 2, 3. 3 are satisfied. Out of 4, 3 are satisfied. Still how many more remaining? 1. So that 1 will be linking with whom? With the hydrogen. So 4 satisfied, children? Yes, for this 4 electrons are satisfied. Come to the second carbon. Now second carbon, you see, as I told, since it's a middle carbon, it is bonding to the first carbon as well as to the third carbon. So let us count the bonds. 1, 2, 3, 4. So 4 are satisfied. Out of 4 electrons, all the 4 electrons have been satisfied. So does it need any hydrogen? No, it does not need any hydrogen. So it is done. Now let us go to the third one. Third one, how many electrons have been shared? Only 1. And how many more it is left with? 3 more it is left with. So how am I going to complete that bonding? By sharing my electrons with the remaining 3 more hydrogens, because this is the prop hydrocarbon. So the remaining 3 electrons are bonding with whom? With the hydrogen to form a single bond. So satisfied? Yes. 1, 2, 3, 4. Okay, children. So now let us again derive the formula. So skeletal formula is CH. H. Number of carbons 3. Then let us count hydrogens. 1, 2, 3, 4. C3H4. So this is the general formula of water of the specific formula of propine. Fine children. Now let us go to the 4 carbon hydrocarbon. Okay, a triple bond hydrocarbon. Now what is the root name? This is bute. What is the root name? Bute. And it is a how many bond? What type of a bond is existing? A triple bond is existing. So it's a ine. So butene. Then let us construct the structure. Okay. So it's a 4 carbon hydrocarbon. So 1, as usual, step first, draw the single bonds between the total number of carbons. So 4 carbons all have a single bond. Then second step, what type of a hydrocarbon? It's a alkyne hydrocarbon. So there should be a triple bond. So in the between first and second only, let us show the bond. So 1, 2, 3. Clear children? Now let us adjust the remaining electrons. Okay, balance. So first carbon 1, 2, 3 already being shared. So only one electron it is left with. So that will bond with whom? With the hydrogen. Now let us come to the second carbon. Second carbon, as I told, since it is in the middle, it is linking to the first and the third. Okay. So 1, 2, 3 and 4. So out of 4, all the 4 electrons are satisfied. So I need not add any hydrogen over here. So now let us move to the third carbon. So third carbon, again, since it is in the middle, it is also bonded to 2 more carbons. But interestingly, what kind of a bond is existing? It's a single bond. So 1, 2. So how many electrons are satisfied? 2 out of 4. So how many more are left off? 2 more are left off. So those 2 will be going with whom? With hydrogen. Okay. So now this is going to be bonded with hydrogen. Fine. So now let us count. 1, 2, 3, 4. So carbon has satisfied its 4 electrons. Let us come to the terminating one. Terminating one has only 1 electron being shared. So still how many more it is left with? 3 more. So where will those 3 more goes to? They will go with the hydrogen. They will go to bond with the hydrogen. So 1, 2, 3. So now I hope you can count 1, 2, 3 and 4. So satisfied? Yes. Every carbon is having now satisfied with 4 bonds. Now let us again derive as usual. Let us derive the formula. What is the formula? As I told, CH is the general, my skeleton. Okay. Then how many carbons, children? 4. Now, same as in case of alkane and alkene, where there is a general formula being given, even alkyne has got a general formula by which you can derive the specific formula for long hydrocarbon chains. So now, again, here it is CnH2n minus 2. So you observe these two. What is the difference? Here it is plus 2, here it is minus 2. Okay, children. So now that means what would be my formula of butane? 4. So 4, 2n. That means 2 into 4 minus 2. So 2 4s are 8. 8 minus 2, 6. So what is now the formula of butane? C4H6. Now can I confirm whether the formula of propine and ethine are correct or not? Yes, let us check. So 3. So 2 3s are 6. 6 minus 2, 4. Similarly, 2 2s are 4. 4 minus 2, 2. So C2H2. Fine, children. So like this, we can derive the formulas of the long chain hydrocarbons. So in the same manner, you can also derive the formula and the structures of the rest of the hydrocarbons from pentane till from pent till dec. Okay, children. So this also you try to draw the structures. Fine. So thank you. Have a good day.